All right, here we are for practice problem number 2. So this is another gravitational force problem. It's just mixed up a little bit, and it's not astronomical in size. We're talking about two people. So let's take a look here. The gravitational force between two students sitting at their desks in a physics class is 3.2 times 10 to the negative 8th newtons. That's not very big, but that's kind of cool. If one student has a mass of 50 kilograms and the other student has a mass of 60 kilograms, how far apart are the students sitting? So I can't resist telling my really silly little physics joke that I feel compelled to tell you. I feel like I would be doing a disservice if I hadn't told you. And that is that this is one of physicists' favorite pickup lines, right? It if we were in school would be about prom time, and so I would probably bring that up and just let you know that if you are trying to find a way to ask that special someone to go to prom or really whatever it is, and friends, this is transferable, you can use this for the rest of your life. You can let them know, right? Because you are a person, you have mass, and likely that person also has some mass as well. You can tell them, you can say, hey, I just want to let you know that I'm attracted to you. But here's the best part, friends. You can also say, but you know what? You're attracted to me too, the same amount. You with me there? Right? Because they're both there's a gravitational force between you. I don't know. I believe that it will work and I can't wait to hear the results. So keep me posted on that. Okay, back to the problem. Sorry, I had to make sure that I shared that with you. Here we go. So gravitational force between two students. So we're going to write down our givens. So what do we know for givens? We know that the force of gravity between the two students is 3.2 times 10 to the negative 8 newtons. We know that student number 1 has a mass of 50 kilograms, and the mass of student number 2 is 60 kilograms. Nice round numbers there. The question says, how far apart are the students sitting? So what is the radius, or what is the distance between them? We also know, and I should have put this as one of the givens earlier, but I forgot, that the universal gravitational constant between any two objects with mass is 6.67 times 10 to the negative 11th Newton meters squared per kilogram squared. All right, so now where's that equation? Well, it was Fg is equal to big G m1 m2 over r squared. In this case, we need to do a little bit of rearranging because we're solving for r. So I'm going to multiply by r on both sides. I'll do this. I won't skip a lot of steps here. Let me do it. I'm going to multiply by r squared on both sides. So my r squareds are going to cancel. And then to get rid of my Fg, I'm going to go ahead and divide by Fg on both sides. So those are going to cancel, and that will give me my new found equation. So r, oh wait, I have to then undo a squared, square root it, right? So r is going to be equal to the square root of g m1 m2 over fg. All right, we're ready to plug in some numbers now, I think. So here we go. I'm going to write it over here just so I've got a little more space. So r is equal to the square root of 6.67 times 10 to the negative 11th Newton meters squared per kilogram squared times mass 1 is 50 kilograms, mass 2 is 60 kilograms, and the force between those two people is 3.2 times 10 to the negative 8th newtons. All right. So again, this is the same thing that I mentioned before. If those, if that scientific notation is causing you stress, then feel free to take this in as many steps as you want. Again, you can do the 6.67 times 50 times 60, and then divide that by 3.2 to find that value, and then do the same thing with your exponents, and then square root your answer at the end. Okay, so make sure you do that square root at the end with that value. Um, but you can absolutely do that. There is no harm in that, no judgment, whatever works for you. The answer that you should come up with for the distance between those two students is 2.5 meters. Okay, so if you're sitting on one end of a table and they're sitting like at the next table over, something like that, then that's going to be about the distance to have this force between those two people. All right. I'm going to go ahead and jump to question number 3 as well in the same video, just to keep it a little simple here. So practice problem number 3, we've done 2 problems that had to do with gravity, and now we are on to some electricity. So here we go. We've got a helium nucleus. You guys know helium. You've seen it before, probably in chemistry or other science classes as well. A helium nucleus has 2 protons, and um, each of them has a charge of 1.6 times 10 to the negative 19th coulombs. We talked about that earlier in the notes. It says determine the magnitude of the electric force of this nucleus on an orbiting electron if the nucleus is about 4.9 times 10 to the negative 11th meters away from the electron on average. So here's the fun thing, right? Y'all know about electron clouds. Like the distance is not going to be perfect. So this is just kind of a general idea, but I think it's pretty fair anyway. Okay. And the question says, is it attractive or repulsive? I just realized that on the first question, I never answered that. Gravity is always attractive. In this case, let's answer this question right now so we don't forget. We have got protons, 2 protons, and they have a positive charge. And you've got 1 electron, and it has a negative charge. If you have a positive charge and you have a negative charge, those are opposites. So that means that we are going to have an attractive force between them. All right, now let's do the math. Here we go. Okay, so givens, we've got Q1, okay, and that Q1 has 2 protons. So the charge here is going to be 2 times 1.6 times 10 to the negative 19 coulombs. Do some fancy multiplication real quick in my head, and that would be what, 3.2 times 10 to the negative 19 coulombs. So that's the charge of the first object. Oops, that looks really ugly. Let me fix that. That's the first object. So that's the nucleus of that atom. Okay. Charge 2 is going to be the electron. And I don't know if you remember from our notes, but we said that the electron has the same charge as a proton, but it's negative. So it's going to be negative 1.6 times 10 to the negative 19th coulombs. Okay. We know that the distance between them, according to the problem, is 4.9 times 10 to the negative 11th meters. So they're very close in our general scale of things, right? Okay. And we know that the Coulomb constant is 8.99 times 10 to the ninth Newton meters squared per Coulomb squared. And the question that we're trying to answer is, what is the force that's acting between the two things? Okay. The equation that we're going to use, it looks very, very similar to the gravitational force equation, right? F is equal to some constant times 2 of something divided by radius squared. In this case, it's Coulomb's constant times charge 1 times charge 2 divided by the radius squared. And I think we're ready to go ahead and plug in some numbers, so let's do it. So we've got 8.99 times 10 to the ninth Newton meters squared per Coulomb squared times the charge of the nucleus, which is 3.2 times 10 to the negative 19th coulombs, times negative 1.6 times 10 to the negative 19th. Oh no, I'm running out of space. There we go. Coulombs. We're going to divide all that by the distance between them. So that's the 4.9 times 10 to the negative 11th meters. And don't forget to square it. You got to remember to square it. Okay, so when you multiply those things together, it comes out to be the force, the electric force between them is negative 1.9 times 10 to the negative 7th newtons. Now, a couple of things that we need to note here. First of all, don't forget to do the square because that square matters. This negative sign here is a little bit funny because we haven't really talked about what it means. So here's the thing. If you have a negative sign, all that that means, all that it means is that it is an attractive force. Okay? If you have 2 positive charges, you would get a positive answer. If you have two negative charges, you get a positive answer, right? Because negative times negative equals positive. And in both of these cases, you would have a repulsive situation. But anytime you have a positive and a negative, when you multiply a positive times a negative, you're going to get a negative, and that will give you an attractive force. Okay, so that negative doesn't mean up, down, right, left, any of that, because that doesn't really make sense when we're talking about this sort of thing. Instead, it just means that it's an attractive force. All right, again, if you have any questions, you want any help with anything, don't hesitate to reach out. Thank you guys so much for hanging out with us and have a wonderful day. Stay safe, stay healthy, be well.